Here we are given several resistors arranged in this way, and we have to find the equivalent resistance between points A and B. So the values of these resistors are given by these numbers. And here, if you notice, these two resistors are in parallel, so the equivalent resistance between of those two resistors is given by this. So the equivalent resistance is just 12 times 6 divided by 12 plus 6. And these two resistors are also in parallel, so their equivalent resistance is given by this. So the equivalent resistance is 8 times 4 divided by 8 plus 4. So now we can replace these two parallel combinations of resistors by their equivalent resistances. So if we draw the whole thing again, we can replace those parallel combinations by just single resistors. So here the value of these are given by the values of the equivalent resistance. The resistor in the middle stays the same, it was just 5 ohms. So the equivalent resistance of this whole thing is just the sum of these three values, because now they're in series and you can just add them. And the sum is given by this. So the equivalent resistance between points A and B is about 11.7 ohms. Now the total current flowing between points A and B can be found in this way. We know V equals IR. We know the potential difference between A and B is 35 volts. We know the equivalent resistance between point A and B is 11.7. So we can find I. And I is about 3 amps. So that's the total current flowing from points A to point B. So that's exactly the same as the current that's going through the middle resistor. So now if we consider the two combinations of parallel resistors that were on the sides as being replaced by their equivalent resistances, now we can calculate the potential difference across them. So the potential difference across the two parallel combinations of resistors can be found in this way. We know for the first parallel combination, we know that the potential difference across those two ends equals IR, where I is the current going through that equivalent resistance times the equivalent resistance of that thing. And the current was 3 amps, and the equivalent resistance of this thing we already found, so that gives you 12 volts. So we know that the potential difference across this parallel combination of resistors is 12 volts. So now we can do the same thing for the second parallel combination of resistors, the one that was on this side, because we know that the potential drop across this combination of resistors is equal to the current times the equivalent resistance of that thing. And that gives us 8 volts. So now we know the potential drop across this combination of resistors. So now our circuit looks like this. That's point A and point B. And we know that, well, these are the values of all the individual resistors. But we know now the potential difference across each section. So the current going through the resistor of 12 ohms is just the potential difference across the resistor divided by its resistance. And it gives us a value of 1 amp. The current going through the resistor of 6 ohms is 2 amps. And in the same way we can calculate the current, well, the current through the resistor of 5 is just 3 amps. It was the same as the current from point A to point B. But the current through the resistor of 8 ohms is just the potential difference across the resistor divided by its resistance. And the same for the other resistor. The resistor of 4 ohms is just the potential difference across that resistor divided by its resistance. So we get these values for the currents through each of the resistors.